Anyway, we're going to catch up on stuff that we had done before. So we're going to have a quick look at what we did, and we're going to continue on with the trigonometry. So this was one of the things we did. I'll give you your test. Will somebody stop me talking at about 12 o'clock, please? 1 o'clock even. So here we go. So this was one of the things we did. The unit circle. So this is a little bit of revision for most of you, I hope. And we learned that if we knew the coordinate, the x-coordinate, then we knew the cosine of the angle, and if we knew the y-coordinate, we knew the sine of the angle. So therefore, I now know by looking at this diagram that the cosine of 0 is 1, that the sine of 90 is 1, that the cosine of 180 is minus 1, and the cosine of 270 is 0. I know that by looking at that picture, the unit circle. Now, obviously, you can type it into your calculator and that'll tell you the same story. But this is what we learned. We also learned that if I did this, and I'm waiting for this to come up in the exam for years and it never did, prove that the sine of 45 is 1 over root 2. And the method we used, and this is on page 234 in your book, the method we use is to draw an isosceles triangle with a 45-degree angle, work out that to be root 2, and you can now see by looking at that picture that the sine of 45 is the opposite over the hypotenuse, the tan of 45 is the opposite over the adjacent, and the cosine of 45 is the adjacent over the hypotenuse. And you can tell that the sine, cos, and tan is 1 over root 2, and etc., etc. And we also did 60 degrees and 30 degrees by drawing an equilateral triangle and dropping that down, and that becomes 1, and this is 60, and this is 30. And if you do that, this becomes root 3, if you do a little Pythagoras there. And you can now see that the sine of 60 is the opposite over the hypotenuse, root 3 over 2. The cosine of 60 is 1 over 2. The sine of 30 is 1 over 2. Hopefully you can tell that by looking at it. And in your head now, looking at the picture, tell me what the tan of 30 is. Looking at that picture, what is the tan of 30? Hopefully you're getting 1 over root 3. The opposite over the hypotenuse. 1 over root 3, the tan of 30. So we learned how to do all of that. And that is the little grid that's in your log tables on page 13, I think. You should now be able to tell, without going to a calculator or without going to a set of tables, well, maybe you might need to go to a set of tables, but you should be able to tell the sine and the cosine of 0, 30, 45, 60, 90, 180, 270, etc. All of those angles. All of those what we call nice angles. Well, what I call nice angles. Should be able to look out all of those. Something else that flashed into my head there now as I was talking about that. What was it? It's gone. Well, I just think, what was it? Oh yeah. The tan of any angle then is the sine divided by the cosine. So in this case it's 0. In this case it's infinity. In this case it's 0. And in this case it's minus infinity. Remember that the tan of any angle is the sine of the angle divided by the cosine of the angle. So therefore I can get the tan by just dividing the sine by the cosine. If you look at it at any stage, you can do it for any of them. It will work out okay. So therefore I can work out the sine, the cosine, and the tan of any of those nice angles, the nice little ones. Okay, we can even do, I'll show you something else. So we can even do a little bit better. I can look up the sine of 210 degrees without a calculator. So not only are we able to do 0, 30, and 61, all those, I can look up funny little ones as well. The sine of 210. And the way we do that is with the help of a diagram. And the help of this, do you remember this? CAST. Who remembers what that means? Look at that. Right, CAST. Who remembers what that means? They're all positive in this area here. The sine of any angle between 0 and 90 is positive. The cos of any angle between 0 and 90 is positive. And the tan of any angle between 0 and 90 is positive. In the second quadrat, this is a quadrat, in the second one, only the sine is positive, the other two are negative. In this one, only the tan is positive and the other two are negative. And in this one, only the cosine is positive and the other two are negative. So here I go. If I want to look up the sine of 210 without a calculator, I draw a diagram. And I draw in where the angle is. It's going to be there. And I put a dot to the nearest x-axis, most important, x-axis. And the angle to the nearest x-axis in this case would be 30 degrees. If I want to go 210, it would be 180 plus 30. So the nearest x-axis is 30 degrees. So that's what we call the reference angle. So I will look up, if I'm looking up the sine of 210, I will look up the sine of 30 instead, which is a half. And then because only the tans are positive in there, I put a minus sign in front of it. So there's a bit of work in that now. It's very easy to hit a button on the calculator, sine 210, and you get minus a half. Here is how we do it without a calculator, with the help of that little grid from the log tables. We can actually do it nice and slowly, but I need the reference angle. I need to know what angle is it to the nearest x-axis. Now, if they had said 211, then I couldn't do this like this. We're only picking nice angles that are within these 30, 45s and 60s. So I need the reference angle. So I will never look up 210. I will look up the reference angle instead and adjust its SIGN then after that. I will adjust its sine after that. It's up to me to decide what sign goes on it. I'll decide that. Remember, I'm working without a calculator. So I should be able to look up any of those. There should be no issue. The problem is, not problem, you won't get one of those in the leaving cert, probably. Unless they ask you to show your work kind of thing. Show how you work out the sine of 210. Showing your work. There's me showing the work. So I get you to do this one while I'm trying to find a space here for this. Look at that, it's gone huge. I'll ask you to look up the cosine of, let me see, 120. The cosine of 120, please, without a calculator. You can always check your answer in the calculator when you're finished. So, here's my answer, minus a half. You getting minus a half? Kate, you're looking at that a bit funny. You see it, first of all, I decided where the 120 is, it's in here. Yeah, and then my reference angle is 60. So it's 60 I'm going to be looking up. And I put the SIGN then, the cosine of 60 is a half. So I put the SIGN in on that then. Yeah, are we all right in that? Minus a half, are you getting that? Are you sure? Do I need to do another one? Yes or no? I'll give you another one to do. So do the sine, no. Do the tan of 330. The tan of 330. Now you might need your log tables to work out the reference angle, or you can use your calculator to look up the reference angle one if you want. In this case, normally you wouldn't, but I'm asking you, don't look up the 330, just look up the reference angle and you put the SIGN on it then. And it's very easy to check your answer by just typing it into the calculator when you're done. I'm getting a reference angle of 30. You're getting a reference angle of 30? The nearest x-axis, remember? So when you look up the tan of 30, that's what I'm looking up instead. I'm getting 1 over root 3. And because of where 330 is, it becomes minus 1 over root 3. Are you getting that? Minus 1 over root 3? Everybody? Brian, did you get that? You got what? Yeah, root 3 over 3 is 1 over root 3. Yeah, that's how the examiner will know whether you've used a calculator or whether you've used the log tables. There's two of them of importance. Root 3 over 3 is 1 over root 3. And another one you look up is 45 degrees. You get 1 over root 2. I prefer you to see you writing them like the circly ones there. That's how they'll know. That's how I would know as a teacher correcting somebody's test. Did they look it up in the calculator? Because a lot of people won't change that. Whereas if you look up at those numbers in the log tables, that's the way they're written, the way I have circled there. So just be aware of that. It's the same thing. You won't get this in the exam. This is just to complete your education. Right. So we're able to look up the sine of any angle we like now. Well, within the boundaries of those reference angles. So what else did we do the other day that we need to know? Sine of theta is a half. This next 15 minutes now are really, really important. The sine of theta is a half. This is like the day you learned how to multiply in primary school. This is the equivalent of it here now. If you get this right, you'll never again worry. If you didn't learn your 2 times tables, you're probably still worrying. Sine of theta is a half. To be honest with you, myself, I missed a day, the very first day we did trigonometry in school, in secondary school. And geez, it took me weeks to get the hang of it when I came back the second day. Well, I probably missed more than one day. I missed 2 days, I think. And I didn't know what they were doing. It was like Greek when I came back. It takes a while. So if you miss it, you need to go back. You really do need to go back and get your head around it and sort it out. Anyway, the sine of theta is a half. So how do I work out what theta is? Now, because of this CAST, we know there are 2 places that the sine of an angle is positive. One of them is there, and one of them is there. So in the first quadrant, sine is positive, and in the second quadrant, sine is positive. Now, this you need to do every time. This is solving trigonometric equations. We need a diagram every time, and once we put the diagram in, we put in the red dot, and I use colors all the time, as you can see. We put in the red dot, it's the reference angle we're now going to get. So here is the reference angle we can get from here. The inverse sine of a half. So the reference angle is 30 degrees. Now I'm not writing in the degrees because my degrees look like circles. You think it was 300 I was writing. So I put in the red dot. So I haven't even worked out the question yet. There is my reference angle. Then to get the actual angle, I go from there and we always measure an angle from here. So the real angle is theta is equal to 30, but theta could also be 150. I'll put in the degrees now, all right. So theta is 30 degrees or theta is 150. So there are a couple of steps. Step number 1 is the diagram. Step number 2, most importantly, is the dot. Step number 3 is calculate the reference angle. And step number 4 is calculate the real angle. So the diagram is important. Whereabouts is the answer going to be? Whereabouts is the answer going to be? Then we put in the dot that decides on the reference angle. So step 1 is here, step 2 is here, and step 3 is here in this box. Any questions with that, anybody? No? You okay with this, mate? You probably did this before anyway, maybe. Did you do, how many people did this before? Oh, your friends, so your friend. Right, if we have a sine, I mean an SIGN, the sine of theta is minus a half. Same old story, the diagram. What I'm now doing sorts out the minus for me. I'm no longer interested in the minus. Once I've done that, I'm no longer interested in the minus. Gone. That's step one done. So that's step one done, the diagram. And the dot. Step 1 and 2 done, in fact. What I now do then is the dot is equal to the inverse sine. No, look at it, no minuses in there. No minus. The inverse sine of a half. Never put the minus into the calculator like that. So then the reference angle is equal to 30 degrees. So now my diagram looks like this. 30, 30. So my real angle then, as you can see, theta equals 210 or theta equals 330. Now you will need practice at these. You will be doing them tonight, in fact. This is what your homework tonight is all about. I sent you on the solutions to your test in the classroom. Hopefully you got it on classroom during the week. Okay. Let me just rephrase that question. The sine of theta is equal to minus a half. It could also be written like that. Or it could be written like this. Or it could be written like this. There are 4 ways of writing the same question. The sine of theta is minus a half, or 2 sine theta equals minus 1, or 2 sine theta minus 1 equals 0, or in fact cosec theta is equal to minus 2. Now that last one is a little bit funny. The cosec of theta is equal to minus 2. We never deal with cosec because we've no cosec button in our calculator. So we change cosec to 1 over sine theta is equal to minus 2, which means if I turn everything upside down, sine of theta is equal to minus a half. So it becomes like question 1 then. So in case you, I've never seen one like that, but geez, it's a lovely one to get. The cosec of theta is equal to minus 2. We have no cosec button, so we change it into sine. 1 over sine is equal to minus 2. So then we flip both sides upside down. So the sine of theta is equal to minus a half. Which reminds me of something else, which has nothing to do with this at all. Have you got those written down? Just in passing, on the test, some of you had something like this. Can't remember what it was now. Something like this. 168 plus k is equal to, oh geez, will I remember it now? Something like this anyway, it doesn't matter. Plus root 13 is equal to 2 root 13 or something like that. And what some people did was squared everything and did this. You can't do that. You can't. Look at it, and this is what I wrote in all your books. 3 plus 4 equals 7. 9 plus 16 is not equal to 49, as you can see. You can't square. You can only square if there's only one number on one side and one number on the other side. You can't square easily. To do this, you would have to do bracket bracket. So you'd have to go 3 plus 4 by 3 plus 4 equals 49. Now it will work. You know, because of the plus sign, you can't just simply square both sides. It's too difficult to square both sides there. Actually, what you would do is bring over the root 13 and subtract it from that, and then you'd only get the square root of 168 plus k equals root 13. Now you can square both sides. You have a square root on one side, square root on the other side, off you go. So be aware, a lot of people make that mistake. A lot. I mean a lot now. Made that mistake. Anyway, what else do I need to tell you? Oh yeah, the sine of an angle and the cosine of an angle will always be between minus 1 and plus 1. The sine of A will always be between minus 1 and plus 1, and the cosine of A will always be between minus 1 and plus 1. always, 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 you will never get an answer other than between -1 and +1. So you'll never be asked to do this, that the sine of theta is -3/2. There is no solution to that. There is no solution. Tans, all right. Tans can go anywhere. But sines and cosines, if you look up the sine of 6 million degrees, your answer will be somewhere between -1 and +1. Your answer will be somewhere between -1 and +1. So you'll always know if you're going wrong if something like that happens. So you'll never be asked to do inverse sine of a number bigger than 1. That's that. What else do I need to show you? This. If I tell you the sine of theta is 3/5, find the cosine of theta. That's a nice question. That's actually off your junior cert. The sine of theta is 3/5. Find the cosine of theta. So the way we used to do it at junior cert was this. We would draw, I would still do this way, to be honest with you. I would draw myself a little triangle. That's 5, and if I do a quick Pythagoras, I'll get 4. Now, in truth, I get +or -4, but in junior cert, this is all we'd ever worry about, is the 4. And then we would simply say the cosine of theta is 4/5. So if I tell you the sine of an angle, I'm actually telling you the cosine as well, or I'm telling you the tan. So if I tell you the sine of an angle, you're automatically getting the cosine as well, and the tan if you wanted. The tan in this case is 3/4. So it should never be an issue. But how did I get the 4? I got the 4 by doing a Pythagoras. So I did this. So therefore 25 is equal to 9 plus 6x squared. So x squared is equal to 16. In theory, x could be +or -4. So I could really put that as +or -4. So in actual fact, the cosine of the angle could be +4/5, or the cosine of the angle could be -4/5. There's a funny one. It could be either case. Now we know there is no such measurement as -4. The minus there just simply means that it's measured 4 in that direction rather than 4 in the other direction. It's more a directional thing than a sign or a size, a magnitude. So +or -4/5. How the hell could that be true? Well, if I think about my diagram, where is sine 3/5? It's there and it's there. So the sine is 3/5 here and the sine is 3/5 there based on my CAST. The cosine in this section would also be positive, so that would allow for that one. But the cosine in this section, if that was the one, would actually be negative, which would be that one. So it is possible that if the sine is 3/5, that the cosine could indeed, depending on whereabouts the 3/5 is, what's theta. So, but if the sine of theta is 3/5, it is true to say that the cosine of theta could either be 4/5 or it could be -4/5. Now at junior cert we never bothered with the minus thing because we didn't do this depth of trigonometry. But in actual fact, it is true. Now in junior cert, you see, they would have said something like theta is between 0 and 90. So that means they're telling us it's here. So in that case, then it'd definitely be 4/5. But if I gave you this question, now again, I've never seen this on an exam, I really haven't. But you know, if you're going to be good at trigonometry, you might as well be good at trigonometry. If the sine of theta is 3/5, and I tell you that theta is between 90 and 180, I'm after giving you a big clue there now. You know, so don't just discard this little piece. When you see that stuff written in an exam, they go to the bother of writing that for some reason. There's a reason why they would write that in. So here when I do this, I now know that it's in there. I needn't bother with that line. That line can be taken out of it because I know that the angle is between 90 and 180. Now when I look at that, I definitely know that whatever the cosine of theta is, whatever it is, it's going to have a minus sign on it. I know that now. And all I have to worry now is about the numbers. So 3, 5, and you know yourself, 4. So I know it's 4/5. Very rare. I've never seen it in an exam. Never seen it. But be aware of it. It's in your book. You're going to be doing 1 or 2 of them tonight. There's the clue. Don't always discard that information. They mightn't even say that. They might just say sine of theta is 3/5 and theta is obtuse. An obtuse angle is an angle between 90 and 180. An acute angle is 0 to 90. So they might say theta is acute or theta is obtuse. It ruins a lovely question if you kind of don't get that. So, but look at it. It's all done with detective work. A little bit of detective work. You draw a diagram. Where is sine of theta 3/5? There's two possible places. First quadrant, second quadrant. They have told me it's in the second quadrant. Now I have a little bit of clue about the cosine. The cosine is definitely negative. I only have to worry about the number, and I can do my little triangle to worry about the number. So nice little question. Would ruin a lovely exam question now if you saw something like that. Right. I'm going to give you one or two of these to do now before we move on another little gear. Keep an eye on my time there. So I'm going to ask you to do this one. If the cosine of x is minus 1 over root 2, find where x is between 0 and 360. Find x. Or find x's. There's a couple of x's. All my x's live in Texas. So cos of x is minus 1 over root 2. Find x. Comes up, this particular one we're just after doing now, that type of one comes up in trigonometry, it comes up in complex numbers, it comes up in calculus, and obviously it comes up in trigonometry itself. Did I mention that? So it does come up in all of these. So it's very, very important what we're doing right now. This is my line again, method maths. Everybody in the whole country can get 70 to 80% in maths if they learn the methods. What happens with people is they don't learn the methods. They're too focused on everything else, not to bother with the simple stuff. Get the simple thing right, and everything else will fall into place. I guarantee you that. You know, as they say in hurling, take the points, the goals look after themselves. It's the same story here. Do the easy bit first. Do the easy bit. Do the method maths. Learn how to differentiate from first principles. Where are you going trying to do heavy stuff when you can't do differentiation from first principles? Method maths. What we've just done is method maths. You keep doing those until you're able to do them. Some people can get it first go, some people takes a little bit longer, but in the end, by the end of the week, everybody can do it, and we can move on to the next bit. Just going up a gear here now. The sine of, oh no, I'm going to go back to that again. I need to do something else with you first. The sine of x is a half. Right, so here's our little diagram. There and there. There's my reference angle in there, and we know the sine of x is a half. I know that the angle is 30 degrees. So there's 30, and there's 30. So my answer is 30 and 150. 30 and 150. However, supposing I did this. So there's one angle, and there's the other one. Supposing I did this. I went all the way around in a circle and back up to there. Now I'm still landing in the same spot. Now what is that green angle? What is it? X is equal to 390 degrees, as you can see. And if I type into my calculator the sine of 390, believe it or not, I get a half. So hang on a second, there's more than one answer here then, there's more than two answers. We were saying up to this that x is between 30 and 150, and that's it. But in actual fact, that somebody could say, well, there's an answer. Or I could go this orange angle. I could start here, go all the way around the circle, come back as far as here. Now what's that? 360 and 150, it's 510. If you look up the sine of 510, you will actually get a half. Or I might decide to go around twice, come back up to here. Now we're talking twice, 720 plus 30, we're talking 750. Hopefully when I type in the sine of 750, if I've done my multiplication right, I get a half. So there's more than two answers here. We've been dealing with answers up to this. In fact, what I wrote beside that in most cases was this. Now maybe I didn't do it in all cases, but there, I should have written it in all cases. That tells me only give me answers between 0 and 360. So that's why we've always only operated with those two. But if I didn't have that in, then I'd have to give all of those answers. And how many circles do I stop at? I don't. So here is actually the answer to that. Move. No move. Look at that. I have to move in the whole diagram. This is the answer. X is equal to 30 degrees and X is equal to 150 degrees. But watch this bit. Plus as many circles as I like. That's what n times 360 means. If n was 0, there'd be no circle. You just go up 30. If n was 1, you do 30 and then do a full circle all the way around. If n was 2, you go up 30 and then you do 2 circles all the way around. But you still land in the same spot. This is what we call the general solution to what we've just done. The general solution. I'll show you another one in a second. So what we do is we get the specific answer first, 30 and 150, and then we stick on an n360 onto both of them. And that gives me every possible answer to x. X is 30 plus n times 360, and x is 150 plus n times 360. As many answers as we like. I'd have to sandpaper my hands when I go home, would you believe that? It's just not moving this. It's very slow to move it. I'm sorry now, I'll just show you that again now. If I was asked that the cos of x is minus 1 over root 2, what are the notice the way I have no range in here at all. I'm asked to find a general solution. So we do it in the usual fashion. Here and here. Here's my reference angles there. And I know the answer is 45 degrees, so the dot is 45 degrees. You can take my word on that. I better show you that how I got that. The inverse cosine of 1 over root 2. Notice there's no SIGNs. I do not type in SIGNs into the calculator. I type in the inverse cosine of 1 over root 2. That tells me it's 45 degrees. So therefore my x is equal to 45 degrees short of 180. That's 135. And x is 45 degrees beyond 180. That's 225. So my real answer then, my general answer becomes this. And there we go. There is the general solution to that question. So we just get the ordinary answer and just stick on n360 onto it. So we get the ordinary answer and we stick on n360 onto it. Right. Now we need that for the next question that I'm now going to do with you. Are any questions on that now before I clear it? Please say it now, because that's a big piece of maths. It's a big piece of maths. Right, I'm going to show you this. If I say the sine of 2 theta is equal to a half, not theta anymore, 2 theta. This is a typical leaving cert question now, how to solve something like this. This is a trigonometric equation with a little bit of it, because it's 2 theta. And I'm telling you that theta is somewhere between 0 and 360. So I'm telling you that the answer is somewhere between 0 and 360. Come up with all the possible answers to that. Right, this is the method. We do exactly the same as we normally do. We find our 2 places, put in the dot. So the dot is equal to the inverse sine of a half. So the dot is 30 degrees. So as usual, now here's the change. Now, when we do this, we do the general answer. So here I go with this, n times 360, and explain that to you now in a second what I'm actually doing. So then theta is equal to 15 plus n times 180. See, there's a little bit of extra in this now. 75 plus n times 180. So I got the usual answer, but then I converted it into the general answer and then divided across by 2. So you can see now why this would be a leaving cert question. So we got the usual answer, but don't forget that's not theta, it's 2 theta in this case. So that's only my reference angle there. So very important that, first of all, that we write 2 theta, very important, and then that we do the general answer, and then that we divide across. Now we're not finished yet, believe it or not. What we do then is we let n equal 0, so that means then theta is 15 or theta is 75. And then we let n equals 1, and if we do that, we get theta equals 195 or theta equals 255. And if I try n equals 2, I'm gone beyond the 360, so I can forget about it. So I can forget about n equals 2. It's a bit tight there in the bottom of it. There it is there, a bit better now. So there are my 4 answers to the question then: 15, 75, 195 and 255. There are actually 4 answers to the question. So I divided across by 2, and then I put in n equals 0, and that turned out to be 15 and 75, and then I put n equals 1, that turned out to be 195 and 255. And if I put n equals 2, I'm gone beyond 360, so I don't need it anymore. And if I put those numbers in for, you know, if I looked up the sine of 2 times, remember it's 2 theta, so if I look up the sine of 2 times 255, I should get a half for the answer. Now that's a big one. You can see that in an exam now, 10, 15 marks for that. How to solve a trigonometric equation where there's more than one answer. Now let me show you the most common mistake that people make. Now if you learn this, that this is the mistake, then you know never to do it. What a lot of people do is they go 2 theta equals 30, 2 theta equals 150. I'll only focus on the 30 now for a minute. So they go 2 theta equals 30, theta equals 15. Oh yeah, n360. So they go 15 plus n360. And then they fill in 0 and they fill in 1. So in other words, what a lot of people do is they divide first and then put in the general bit. You do never do that. Listen now, let this ring in your ears. You put in the general bit first and then you divide. So the general first and then divide. And an awful lot of people, once they get 2 theta equals 30, they say theta equals 15 plus n360. No. Divide first. General first, then divide. Remember that now. General first, then divide. So the general equation first, there it is. And then you divide. And then you fill in the numbers. And it's very easy to know how many times you do this. Generally speaking, no, it depends on what the question is asking. But generally, if you're staying between 0 and 360, if there's 2 thetas, then you fill in 2 ends. If there's 3 thetas, you fill in 3 ends. If there's 4 thetas, you fill in 4 ends. So if I was asked to do the sine of 3 theta equals a half, I know that I'm going to be filling in 0, 1 and 2. There's going to be 6 answers to this question. So depending on what that number is, you can figure that out. Now that's a serious leaving cert question. Any questions on that yourselves? I'm going to stop down a second because we need to look at your tests. Anything on that, anybody? I'm going to do a quick one now without stopping. You just watch what I'm doing here because I haven't time to really go through it. Just watch what I'm doing here now. I'll do the cosine this time. The cosine of 3 theta is minus a half. Okay, so we got this. No, not there, sorry. I know you can take my word for it, it turns out to be 60 degrees, so that's 60, that's 60. So I would now say 3 theta is equal to 120 and 3 theta equals 240. Very tempting to divide there. Jesus, very tempting to divide. So then we go 3 theta equals 120 plus n360 and 3 theta equals 240 plus n360. So then theta is equal to 40 plus n times 120 and 3 theta is equal to 80 plus n times 120. And then I put n equals 0, so that gives me 40 and 80. Then n equals 1, so 120 and 40 is 160, and 120 and 80 is 200. And then n equals 2, that's 720 and 1, no, sorry, this one I'm filling into So that's 240, that's 260. And this is 240, that's 320. And if I go beyond that, I'm going to be beyond 360. And I'm going to check my answer then. There's 320. I'm going to put 320 in above. So I'm looking up the cost of 960. And the cost of 960 is minus a half. So I know I've done it properly. There's a speedy version of that now. What did I do different? Nothing that you're not able to do, except don't forget the tempting bit there is the dividing. There's the bit. Once you're there, once you get to there, you should finish it. Dance or something, you have to wait for the music in the background. But anyway, let me tell you about it. The results are going to be, there's a number with a double line underneath and a circle around it. That's your percentage. So in case you think some bits of it there doesn't look right. When you turn the second page, if there's a star on it, I need to see you tomorrow, or I need to see you at some stage. I'll be here every day between 11 and 11:15 every day. Just need to talk. Now, some of these could be very good results that I want to talk about. I want to say, geez, you're doing great, and just be aware of this and be aware of that. So it isn't bad news that you're, in fact, being called to see me. So if you see somebody talking to me tomorrow, it doesn't mean it's bad news. It could be good news. It might be very bad. So I did the test. I said, absolutely. I'm going to start on I'm going to drop these for you. Brian Murphy. Who's there, Brian? Yep. Brian Murphy? Not there. Callum. Jeez, the next step. Blind you. There. Joe. Hannah. Kathleen. Patrick. Yes, I just know the way we are. Jessica. Margaret. We see it. Kate. Lottie. Elliot. Where is he again, Elliot? Be careful. Hayden. Gina, sorry. Fiona. Brian McNamara. There we are. What is everyone? Damien. Raoul. Sorry. Harris. Okay. Ashley. I'll go over that side, Ashley. And Michael. Has everybody got something? Everybody got something? Yeah. Now, let me explain to you. The test. One or two of you, just, I know my own heart and soul, just thought, I know this, I need to do this. Particularly some of you who did this last year. People who did the course last year, some of you who did bits and pieces of it, thought, this is handy, I know, I don't need to revise this, and got caught, I know that. Question number 1, part A. You should be shocked if you didn't get it right. It was an inequality that you kind of knew was coming up. A quadratic inequality. How many times have we talked about it? x minus 5 to be squared on both sides. Multiply by x minus 5 squared on both sides. Genuinely now, that's method maths. Here am I talking about method maths. That is method maths. You learn that method, you learn how to do it, bang, you get full marks. Really, if you didn't get full marks on that, you should have. You really should have. Question part B was method maths again. Now, a lot of you got this right. You filled in the number a half and you divided by whatever. Question number 2. I'll go to part B first. Again, you should be shocked if you didn't get full marks for part B. Differentiate from first principles. Method maths again. You learn how to do it and you go and do it. Simple as. No beating around the bush. You learn how to do it and that's it. Part A was a little bit tricky. It was the differentiation of implicit function. But again, if you learn how to do implicit functions, then you were able to do it. Where people went wrong here in this big time, and I'll be talking about this again. When you differentiated y squared, a lot of you just did y dy dx. You forgot about the 2y dy dx. When you differentiate y squared, it's 2y dy dx. And some of you differentiated the 25 and didn't. You just wrote down 25. So the answer to that first line was this. 2 times x minus 3 to the power of 1 plus 2y divided dx equals 0, not 25. Some of you didn't differentiate the 25 at all. And then you isolated the dy dx on your own. But again, that's out of the book. There's nothing there that's not in the book. That is, learn how to do an implicit function. Question 3, part A, was my gift to you. You had a circle, 911 sitting on the circle, 0, 0 as the center, and you were looking for the slope of the tangent. All you had to do was get the slope between 911 and 0, 0 and invert it. Some of you went around the houses to get it. Some of you did y minus y1 equals m times x minus x1 and got a half equation and worked. It's fine. You will get the answer doing it that way. But you'll be here till tomorrow to do it. But you did. You did. Some of you did that and did it well. Didn't spot. The reason I gave you that was I wanted to see how many people would draw a diagram. Draw a diagram, put in the dot, and once you see the diagram, it'll fall into place for you. Part B, if you didn't get 5 marks on part B, we're in a spot of bother. Can you get the center and can you get the radius of a circle? The next question was the circle again. It was talking about external touching. If you didn't have this written down, then this was your fault. R1 plus R2 is equal to D. If you don't have that written down, there's a bit of bother. External touching is radius 1 plus radius 2 is equal to the distance between the centers. There is a maths equation. All you have to do is fill into that maths equation. If you didn't know that equation, there's where the bother was. Radius 1 we had from the previous page. Radius 2 turned out to be a bit funny. Something like 168 plus k or something like that. 168 minus k in fact. And then the distance between the centers was the distance from 0, 0 to 10, 9, the center of that other circle. But again, this person, I can just show you, has the diagram in. Everything going according to plan. Has the diagram in. If you drew that as a diagram and drew in your 2 centers, you'd see it a mile away, provided you wrote down R1 plus R2 is equal to D. Method maths again. Did I learn that external touching involves R1 plus R2 is equal to D? There is my equation. All I have to do is fill into that equation. Work out R1, work out R2, and work out D. Question number 4, the teams. Believe it or not, people couldn't count in this. 20 people, there's 15 in a team. The captain must always play. This is what some people did. They put the captain over there, 1 choose 1, and then over here, they did 19 choose 15. Sure, the captain is already playing. What the hell is 15 doing here? You only have to pick 14 now. Or some people did 1 choose 1, 20 choose 14. How could there be 20 here if the captain is over there? So it was very simple mistakes that people made on that. And then the one with the 2 players, 2 choose none, and 18, not 19, 18 choose 15. We're not picking any of them. And then 2 choose 1, and 18 choose 14. The bit underneath that, the given one, was a formula job again. A intersection B over B. It was a formula. Here's the formula. Here it is. The problem is I didn't give you the formula. All I said was the probability of A given B. A given B is a formula. A intersection B over B. So I look at my diagram, where's the intersection B? There it is, 0.2, whatever it was, I think it's 0.2. And where is all of B? B was can't remember, B was 0.46, they actually gave it to you. So I think the answer to that is 0.2 over 0.46. And the last bit was from the Leaving Cert 2018, I think. Where did people go wrong in this? I tell you where people went wrong in this. You wouldn't believe this. You were to fill in, it had to end in a 0 anyway, that was one thing. So it ends, that's one choice at the end. And then we have a 6-digit number. Some people used the number 6. So they put in 66661. Why would you put in 6? It's a 6-digit number. That means there's 6 dashes. But there are 10 possibilities to go in first place, 10 possibilities for second place, 10 for third, 10 for fourth, 10 for fifth, and 1 for last. The 6-digit number, there was no 6s. The only 6-digit number was 6 places. What some people did, apart from the 6666, was they used the number 9. Why would you use 9? There are 10 digits between 0 and 9. 10. To count them up. There's 1 to 9 is 9, but 0 to 9 is 10. So there are 10 spaces that you can fill in. And remember, it's a code. It's not a number, so therefore 0 is allowed to go first because it's a code. So it was 10, 10, 10, 10, 10, 1. Think about that. Some of you, I don't know, many of you had 6. You were involved in 6s there. And part 2 was a little bit tricky now, I have to admit. The 2018 one. Well, the only possibilities is you had 2018 blank blank. So you had 2018, there's my first 4 digits, and then blank blank could be 1010. So that's 100 different choices. And then you could put 2018 in second place. So you could have blank 2018 blank. So that's another 1010, that's 100. And then lastly you could have blank blank 2018. That's another 100. So 300 was the answer to that. Now that bit was a bit tricky. But looking at it all in general, there was method maths for 90% of that paper. How do I rate the test? 6 out of 10. Not at all difficult. It's a 6 out of 10 test. I would say it's not a difficult test. It's a nice test. What it told me was who's keeping up with it, who's falling behind. That's all I learned from that. Who's keeping up with what we're doing, who's falling behind. I certainly would think if you got that in your Leaving Cert, if I saw that exam in the Leaving Cert, I'd say you have to be given a gift. If I saw a Leaving Cert paper of that standard, that's a 6 out of 10 test. It's not a difficult test. But I didn't want it to be a difficult test. I just wanted to see who was keeping up. Talk to me. If you need to talk to me, talk to me. You can tip away. I'll see you tomorrow. This is for myself, so that I know which class it is. I'll be putting this hopefully up onto YouTube. Hopefully in this version, because I'm not on this case later on in the day. So at the weekend, we can drop on bits and pieces that we've done. So So I've given you homework for tonight. Some of them involve those questions, messing with those. Is there any question you want to ask me now about that? Nice and steady now on that. I'll be putting this up. Look at, there's probably worked examples in the sheet. Oh, geez, I meant to tell you there's sheets there on the way in. Did you get them? Get them on the way out. Sheets, trigonometry sheets. I'll give you more tomorrow. Right, end of story. Your tests.